Hi everyone, in this video I'm going to introduce an engineering math question related to piecemeal function and variable separable dE. The question is, the height of a mountain is 1867 meters and the temperature at the foot of this mountain is 29.7 degrees. The relationship between the height h and the temperature T is given as, when the height is below 1000 meters, the temperature goes down 0.006 per meter higher, and above 1000 meters, giving a new variable x, where x is equal to h minus 1000 meters. The height x and the temperature T satisfy the equation given here. So please write down the function T of h and calculate the temperature at the notice here, the function T of h is actually a piecemeal function including two parts. In the first part, when h is between 0 to 1000 meters, the information the temperature goes down 0.006 degree per meter higher is just equal to the function given here, dt on dh equals minus 0.006. And we solve this differential equation, end up with t equals minus 0.006h plus a constant, and apply the boundary condition to solve for the constant, which is the ground state. At the ground state, h equals to 0, t equals 29.7. The result for the first part is t equals to minus 0.006h plus 29.7. In the second part, where h is between 1000 meters to 1867 meters, we have a new variable x equals to h minus 1000 meters. The information was in the equation given here, dt plus 0.06 dx on the square root of x plus 0.01 dx equals to 0. We notice here this equation is actually a variable separable dE. We move these two terms on the right hand side and take out the common factor dx, end up with an equation like this. Then we integrate both sides. The result is t equals minus 0.12x to the power of half minus 0.01x plus a constant. Then we apply the boundary condition. However, the boundary condition here, as you may notice, is a result of the first equation. That is when h equals 1000, where x is equal to 0. We calculate t1 using the first equation getting here, because at the same height where h is 1000 meters, these two equations should give the same temperature for t. Then we substitute x by h minus 1000, end up with an equation t equals minus 0.12 h minus 1000 to the power of half minus 0.01 h minus 1000 plus 23.7. The result is written in the piecemeal function form like this, with two functions and the domain after each functions. So that's the function T of h. And the second part is to calculate the temperature at a mountain peak. This is relatively easy as long as you got the piecemeal function here. In order to calculate the temperature at a mountain peak, just substitute the value for h equals to 1867 into the second equation here. Then we end up with a result saying h equals to, when h equals to 1867 meters, t equals 11.5 degrees. So that's the whole video. Thank you for watching.